Today's systems is going to be solving systems by elimination. So let me read these paragraphs. Sometimes solving systems of equations by graphing isn't the most efficient method. There are other methods we use to solve systems. In Algebra 1, we will learn 3 ways to solve systems. In Algebra 2, when the systems get more complicated, you will learn additional methods. In this system, you can eliminate one of the variables by adding the 2 equations together. This is known as the elimination method. After one variable is eliminated, it's easy to solve for the other variable. Remember, our solution is an x and y that make both equations true and is usually written as an ordered pair. For example, solve this system. We have x minus y equals 25 and x plus y equals 71. We want to add the equations. On a side note, in order to eliminate the y's, they have to be opposite signs. Okay, so one of them has to be positive, one of them has to be negative, and they have to add up to equal 0. So when I add these 2 equations together, I see that I have a negative y and a positive y, so when I add those together, they are eliminated. That equals 0. So when I add my 2 equations together, I get x plus x, which is 2x, and then I add 25 plus 71, which is 96. Once I eliminate one of the variables, then I can solve like we normally do, 1-step, 2-step equations. So in this case, this is a 1-step equation, and I'm going to be dividing by 2, and x is 48. Okay, we're not done. We did solve for the x coordinate of our solution. Our solution is a point, an x and y coordinate. At this point in time, you can pick either one of your original equations. So you could pick the first one or you could pick the second one. In this example, we picked the first one. X minus y equals 25. Now that we know what x is, we're going to substitute in x the 48 that we found. So we're going to put in the value we found for x. And now we solve for y. In order to solve for y here, I'd have to subtract. Oh, I see that they added y to both sides here to make y positive, and then they subtracted 25 from both sides to get 23. So my y equals 23. If you need to see that worked out, they had 48 minus y equals 25. Y was added to both sides. That eliminated it there. And we get 48 is equal to 25 plus y, which is what we got here. And then they go ahead and subtract 25 and get 23 is equal to the y. Okay? Now, solve these systems using the elimination method. So what you're really looking for is you're looking at the coefficients, 2 and 4. Those are not alike, so they are not going to cancel out. Let me look at my y coefficients, 3 and negative 3. When I add those together, they are going to add up to 0. So I'm going to add my 2 equations together. I'm going to be left with 6x. That's going to eliminate. That equals 0. And I get 54. Then I solve for x. Divide both sides by 6. And x equals 9. I'm not done yet. I've only found one coordinate. So I need to pick one of my equations, and I picked the bottom one this time because my y is positive. So I'm going to do 4, and instead of x, I'm going to put in my x, 9, plus 3y equals 42. Now I'm going to solve for y. I've got to multiply 4 times 9, which is 36, plus 3y equals 42. Solving for my y term, I need to subtract 36. 3y equals 6. And then I divide by 3 to solve for y, and y equals 2. So my solution to my system is 9, 2. So these two lines would cross each other at 0.92. Number 2, I have a negative x and an x. So if I add those together, they're going to cancel out. So I'm going to add those together. That eliminates. I get negative 3y equals negative 3. Solving for y in one step, dividing by negative 3. And y equals 1. Okay, so I've solved for y. Now I need to go back and find x. I'm going to pick my bottom equation again because my x is positive. So I'm going to have x minus 5 times 1 equals negative 11. X minus 5 equals negative 11. Then I need to add 5 to both sides. And x is equal to negative 6. So these two lines will cross each other at negative 6, 1. So my solution is negative 6, 1. Okay, some more practice problems. Number 3, I have negative 2 and 8. If I add those together, that's not going to equal 0. I have a positive 6 and a positive 6. If I add those together, they're not going to equal 0. This one's a little bit different than our first two examples. I'm going to have to make one of these 6's negative, because if I make one of them negative, then they add up to equal 0. It doesn't matter which one you make negative. I'm going to pick the top one, and I'm going to multiply through by negative 1. Okay? That negative 1 is going to change that positive 6 to a negative 6. And because I have to keep everything equivalent, I have to multiply every term by negative 1. So I get 2x minus 6y equals positive 26. That negative and negative become positive. And I'm going to rewrite my second equation. 8x plus 6y equals negative 16. Now I'm ready to add my equations together. I get 10x, my y's eliminate, equals 10. Solve for x, I'm going to divide by 10, and x is going to equal 1. Now I need to go back and find y. Since they tell us to go back to our original equation, I'm going to pick the bottom one again because I guess it doesn't matter. I'm going to pick my bottom one again. 8 times 1 plus 6y equals negative 16. I get 8 plus 6y equals negative 16. Then I need to subtract 8. 6y is equal to negative 24. Let me come up here. 6y equals negative 24, and I'm going to divide by 6. And y is going to equal negative 4. So these two lines are going to cross each other at the point 1, negative 4. This is my solution. Okay, number 4. Okay, when I add my x terms together, that is going to equal 0, so I don't have to do any multiplying here. They're already going to add up to 0, so that's going to eliminate, and I'm left with 3y equals 6, and then I'm going to divide by 3. Y is going to equal 2, so I found my y coordinate. Again, I'm going to use my bottom equation because my x is positive there. X minus 2 times 2 equals negative 11. I get x minus 4 is equal to negative 11. Then I'm going to add 4. And x is going to equal negative 7. So these two lines are going to cross each other at point negative 7, 2. Number 5. If I add my x's together, I'm going to get negative 4. If I add my y's together, I'm going to get 5. Remember, the key here is I want to get one of those variables to equal 0. Well, these two are the same. I just need to have one of them positive instead of both of them negative. So what I'm going to do, I'm going to choose to move multiply the bottom equation by -1 to change the sign. I'm going to rewrite the first equation. Negative 2x plus 4y equals 10. And now I'm going to multiply my bottom equation by -1, which is going to give me a positive 2x, a negative y, and a -1. Now these will add up to equal 0, and I can add the equations together. My x's will eliminate, and that will leave me with 3y is equal to 9. I'm going to divide both sides by 3, and y is going to equal 3. So I have my y coordinate. Now I'm going to find my x coordinate, and again, it doesn't matter which equation you use. I'll use the first one since I seem to be favoring the bottom one. So I'm going to have negative 2x plus 4 times 3 equals 10. I get negative 2x plus 12 is equal to 10. I'm going to subtract 12 from both sides, and I get negative 2x is equal to negative 2. I'm going to bring that up here. Negative 2x is equal to negative 2. I'm going to divide by negative 2, and x is going to equal positive 1. So that means that these two lines are going to intersect each other at the point 1, 3, and the point 1, 3 is my solution. Okay, number 6, if I add my x terms together, I get 0, so that's good. I can go ahead and add them together, and that's going to eliminate. That's going to equal 0. When I add negative 5 and negative 5 and 1, I do get negative 4, and then I get negative 8. 2 plus negative 10 is negative 8. So I'm going to divide by negative 4, and y is going to equal positive 2. I'm going to go ahead and put it back into my first equation because my first equation has a positive 3x. Minus 5 times 2 equals 2. I get 3x minus 10 equals 2, and I'm going to add 10 to both sides. 3x is equal to 12, and now I'm going to divide by 3, and x is going to equal 4. So these two lines are going to intersect at the point 4, 2. So 4, 2 is my solution for both equations. Number 7, setting up and solving a word problem using systems of equations and the elimination method. A convenience store sells coffee in small and large sizes. More than likely, if you pay attention to this, this is going to be your variables. One's going to be small, one's going to be the large. One customer buys 2 small coffees and 3 large coffees for $5.20. So if I go ahead and take this one and write an equation, he buys 2 small coffees and 3 large coffees, and it cost him $5.20. Okay, then another customer buys 2 small coffees and 1 large coffee for $2.80. Okay, so second customer, he buys 2 small coffees and 1 large coffee, and he pays $2.80. So based on that information, they want us to find out what the prices are for a small coffee and a large coffee. Okay, well, if I look at my variables and I add them together, I get 2 plus 2 is 4, and I get 3 plus 1 is 4. So I have to look at my coefficients because I can't add them together yet. I won't eliminate a variable. I have 2 2's, so I'm going to change one of these 2's to a negative, and I'm going to choose the bottom one because those are smaller numbers, and I'm going to multiply by -1. I'm going to rewrite my first one. 2 smalls plus 3 larges equal $5.20. And then now I'm going to multiply my bottom equation by -1. So I'm going to get negative 2s minus the 1 large, and I'm going to subtract the $2.80. Okay, so now I can add these together, and my smalls will eliminate, and I get 2 larges equal $3.60. Okay, I'm going to bring that up here. 2 larges equal $3.60, and I'm going to continue to solve by dividing by 2. So that tells me that a large drink costs $1.20. I made a mistake. I need to go back and correct. This is not $3.60. It's $2.40. So when I subtract $5.20 from $2.80, I get $2.40, not $3.60. Okay, so I got to replace that with $2.40, and I'm going to divide by 2, and my large is $1.20. Okay, so now that I know what my large is, I need to find out what my smalls are, and I plug it back in. I'm just going to plug it back into the first equation. So 2 smalls plus 3 larges at $1.20 equal $5.20. So 2 smalls plus 360 equal $5.20. And then I'm going to subtract 360 from both sides. And I get 2 smalls are equal to $1.60 and divide by 2. And my small is equal to 80 cents. So my solution is going to be 80 cents for the small and $1.20 for the large. So you would have to be able to pull your equations out of the word problem. They're going to be set up similar to this. They're going to tell you what the variables are. In this case, they were small and large. And then they're going to give you the scenario. One equation is somebody buys 2 small and 3 large coffees for $5.20. And another customer buys 2 smalls and 1 large for $2.80. Remember that if you add your equations together and one of them does not eliminate, you want to look for the coefficients to be the same and then be able to multiply one of the equations by -1. And that will allow you to eliminate the variable.